Hello! So this is going to be video 1 of 2 here as we go through the first 2 pages of today's assignment. So this first one is about 2 girls who are standing 78 feet apart, and they each have a ball and they're throwing it towards each other. So I'm going to draw a sketch of the problem below. We have Caroline and Bea, 78 feet apart. They throw a ball towards each other from an initial height of 5 feet. Caroline throws her ball with that initial velocity, that angle, and so on. So we have a Caroline. Let's just say Caroline is over here. And 78 feet away, we'll say over here, we have Bea. What I'm going to do for this is I'm going to consider Caroline at the order pair 0, 0. That would make Bea's order pair 78, 0. So that'll come into play later on. Now for the diagram. So Caroline throws her ball 45 miles per hour at 44 degrees, so it goes something like that. And then Bea's goes something like this. The actual motion of the balls would look something like this, and Caroline's might go something like this, and they'll cross. Maybe not at the same time. We're going to find out about that, but that's generally what's happening here. So now let's get into the equations for Caroline. Her x component would be 45 cosine of 44. Times t. This is essentially distance equals rate times time. Distance is the x. This is the rate, that's how fast it's going, and then the time t. The y component is going to be negative 16. We're using feet again. Plus 45 sine 44t, and then plus the initial height of 5 feet. So that's for Caroline. Now let's go to Bea's. Now Bea's x equation is where something kind of new happens here. She's at the order pair 78, 0. So she's starting out 78 feet to the right of where Caroline is. And she's throwing the ball in the opposite direction as Caroline. Now one option is to put 39 is her angle, 39 degrees here, and then find out what that general angle would be. But what I'm going to do is, because it's going in the opposite direction, I'm just going to say that she starts at 78, so that's her initial horizontal distance away. And because she's throwing the ball backwards, it's going to be minus whatever the component is. So in this case, the component would be 41 cosine 39 times t. For the y component, negative 16t squared plus 41 sine 39t plus 5. So the distance, the vertical one does not change signs because both balls are going up in the air. So the height is increasing, so there's no need to change that. Okay, now for part B. Whose ball hits the ground first? Well, hitting the ground means the height is 0. So we're looking for the time for when the y value is 0, and then we can plug that time into the x equation to see where it is. So I'm going to start with Caroline, set 0 equal to her y equation. And then I'm going to do the same thing for B. I might as well just write it out while I'm over here. Okay, so on the calculator, I actually already have these in my y equals, as you can see there. And I'm going to go to the window now. So I'm in the regular mode, I'm not in parametrics. And in the regular window, I'm going to go from 0 to, actually negative 2 to 80 is probably good. We'll see both starting points. The y min would be the, the x is actually time in this case, so that's going to be way too much time. We'll just go to like 8 seconds. The y value, the height, starts at 5, so I'm going to go from negative 5. Maybe it gets a little high here. I'll go to 40 and see what happens. Okay, so let's sketch the graph and see what it looks like. Okay, so let's find out how long it took to hit the ground. Second calc. Zero. There I am on that equation. And the right bound, I get time equals 2.102. Now I'm going to take off that first equation, so the second one is going to graph now by itself. And find the 0 again. There it is. And we get 1.79. So I'm thinking Caroline is going to stay in the air further. Well, it's definitely staying there longer. I'm thinking hers is going to go a little further. Let's find out. So x equals 45 cosine 44 times 2.102. And then over here, we'll just do this part of it because that's the distance. 41 cosine 39 times 1.79. Okay. I get 68 feet. So Caroline's ended up being 10 feet short of Bea, but pretty far throw. And yes, Bea only made it 57 feet. So this was Caroline, so Caroline was the winner here. Okay, the final question on this page, will the balls meet in the air? So they definitely cross at some point here. They both threw the ball far enough where they will cross, but do they cross at the same time, and are the heights the same? So here's how we're going to do this. There's a couple ways of doing it. What I'm going to do is I'm going to find out the time it takes until the x-coordinate is the same. So as you look across this pink line here, at some point, both Caroline's and Bea's will be at the same x-coordinate. If they are also at the same y-coordinate at that time, then they will intersect. So here we go. We're going to set the x equations equal to each other. 45 cosine 44 times t equals 78 minus 41 cosine 39 times t. So essentially, we're going to add this over to the other side. So that coefficient, if we do it all out, would be 45 cosine 44, and then plus 41 cosine 39. And we get 64.23. So 64.23 t is equal to 78. So I do 78 divided by that answer, and I get 1.214. Now what I'm going to do with this is I'm going to find out if the y values happen to be the same. So if I plug in 1.214 in for those y values, let's see what happens. And I'm just going to use the graph here because it's already in the calculator. So if I go to value, x equals 1.214, we have 12.7 feet high. This is for Bea. Now I'm going to go back into y equals, take this one off, put this one on, and I'm going to do the same thing with the value 1.214. And I get 19.37 feet. So when these balls are directly on top of each other, they have the same x value. Looks like Caroline's is almost 7 feet taller than Bea's, so they definitely do not cross. The answer is definitely no. Now, if these are really close, like within a couple inches, the answer would be yes, because the baseball itself has a certain diameter, so if they're close, you could just use your best judgment call. But baseballs are certainly not 7 feet in diameter, so these will not hit each other. Get ready for video 2.